I generated a couple different sets of numbers, and now your job is to match these numbers to the set that they belong to based on the characteristics of these elements. Now, I would like you to pause the video because afterwards I'm going to give you the answer. We're going to work through them together. So I've assumed you gave it a go and you found these problems pretty easy. Now I'll give you the answers just so you can check, and I'll give you an explanation for each set. So here are the answers. So for the first set, we have x is an element of the natural numbers. Now this is because all these numbers are, first of all, integers. They don't have any decimal parts, and all these numbers are greater than 0. Keep in mind, we do not, for our definition, we did not include 0 as part of the natural numbers. The next set, we have x is an element of the integers. Here we can see x, it can be 0, -6, and -85. Clearly, none of these numbers can be part of the natural numbers. So they must fall into the next category, which is the integers. Third, we have x is an element of the rational numbers. This is because all of these numbers can be written as the fraction of two integers, for instance, p and q. So keep in mind, the third element, we have 6.7, repeat a bunch of 7s, however, it's terminating. The reason why this is considered rational numbers is because all rational numbers, it's been proven, they have terminating decimal, and even if they don't have terminating decimal, they are repeated, so we can find a pattern. The fourth set on our list, we have x is an element of the real numbers. Now, despite 3.8777 and 1/3 being rational numbers, we also have pi and the square root of 2. These two are clearly not rational numbers. Therefore, we must include them. We must include the other two numbers, the next set above it, which is the real numbers. The reason for pi and square root of 2 being irrational numbers is because pi and square root of 2 have been proven to have infinite non-terminating decimals that do not repeat. Now, for the fifth set, we have x is an element of the complex numbers. Now, keep in mind, we must remember that complex numbers, they can be written as a plus bi, where a and bi are not integers, they're real numbers. So a, b are real. So you might be thinking, well, why is 7 and why is a 9 complex number? It's precisely because a and b are real numbers. And by our definition, real numbers also include 0. So in the special case, we have 7 plus 0i. b is equal to 0, which is perfectly valid. Same goes with 9. For the last set, it's a similar story to above, however, we also have something like 42i. This is basically the same thing as what we had with 7 and 9 above. However, 42 is just a special case where b is 42 and a is equal to 0, which is, once again, also allowed with complex numbers. So hopefully you found this useful and you got all these questions correct, because these are not that hard. Hopefully I'll see you in the next video.